The root test. The root test is another one of our infinite series tests for convergence or divergence. It has three stipulations. 1. If L is less than n, the series is absolutely convergent. 2. If L is greater than 1, the series is divergent. 3. If L equals 1, the series is inconclusive. And we'll see how to get L. So let's start off with an example problem of sigma from 1 to infinity of n over 2n minus 1 to the n. So instantly, off the bat, because it's going to n, everything is raised to n, we know to use the nth root test. So we convert this to limit notation, limit n to infinity of the square of the root n of n over 2n minus 1 raised to the n. And from there, we know that n raised to the nth power to the root n cancels. So we're left with limit n to infinity of n over 2n minus 1. And if we take the limit, we can tell by dominance that n and 2n are the same power, leaving us with 1/2. And if we check back with our root test rules, we can tell that 1/2 is less than 1, which makes this series convergent. Let's look at another example. Sigma notation, 1 to infinity of 4n to the third plus 1 over n to the third plus 87 raised to the nth power. We can instantly know to use the nth root test because everything on the top and bottom are raised to the nth power. Put this in limit notation. And we can tell that everything raised to the nth power to the root of n cancels. So we're left with limit n to infinity of 4n to the third plus 1 in the numerator over n to the third plus 87 in the denominator. If we take the limit, we can tell by dominance that n to the third is the same power as n to the third on the bottom. So if this series were to go to infinity, we'd be left with 4. 4 equals L. And if we check with our root test rules, that 4 is greater than 1, making the series to be divergent. That's pretty much all we need to know for the root test, except if you ever get 1, you know that you can't use the root test, because that means it's inconclusive.